for in-theater drone productions. So without further ado, I'd like to introduce the first of our six startups who will be presenting. And I'm not sure who the six will be. And again, this is our innovation showcase judging panel. Defense security. I probably should have forwarded the slides before just reading. And so first up is Etherform. And so, Chris, welcome to the stage.
Hi there. My name is Chris Barnes. I'm the CEO of Etherform. We're building a distributed swarm drone defense system. Our system combines RF sensing, computer vision, resilient mesh networking, and software guided interceptors to defend against low cost drone threats. Let's see, next slide. Today, cheap drones have changed the economics of warfare. Aircraft, radar, and logistics nodes are now threatened by low-cost drone threats at very long ranges. What used to require sophisticated air power can now be done with systems that are cheap, attritable, and fielded at volume. That means we also have to change. It has to be distributed, scalable, and affordable. Today, the cost curve is broken. Low-cost attack drones and one-way munitions are used at scale, and the systems often used to defeat them are expensive, limited in number, and unsustainable in a prolonged fight. The winner is the side that detects earlier, fields at volume, and responds affordably. That's exactly what we're building. Our answer is a distributed kill chain for low cost drone threats. First, we detect early using a collaborative swarm with RF and electro-optical targeting. Then we build a common operating picture through shared tracks, mesh networking, and geolocation. Finally, we create a path to defeat with affordable interceptors integrated into the network. So we're not starting from zero. We already have deployed RF products with existing DoD and federal lab customers. We are profitable operations. We have profitable operations funding product development and in-house electronics, composites, and rapid manufacturing. We've also de-risked core technology and manufacturing. Our company was founded in 2022. In 2023, we deployed our first RF products and were awarded SBIRs with the US Air Force. In 2024, we began UAS development, and in 2025, we advanced our directional communications and multifunction aperture work. And we also established our composites manufacturing facility. This year, we've started flight testing our UAS, which I'll introduce in a moment. And so we're a profitable company building on real technical progress. First product is our medium range reconnaissance UAS. This is a Group 2 sensing, communications, and processing node on the tactical edge. It is designed for targeting through RF and electro-optical sensing. Targeting information is shared back through nodes in the network in the swarm through a mesh network back to the command and control platform. So this is the wedge that will get us into DoD programs first. From there, we expand into affordable interceptors for frontline and perimeter defense. This interceptor is designed to integrate into our sensing and networking stack. It's a software guided system designed for low cost per kill and high volume manufacturing. Our plan to scale is to start with our current facility for low rate initial production. We can leverage contract manufacturing to scale surge capacity as necessary, but in the medium term, we have the building space available to scale our manufacturing up by 8 times within our current space and our current property, supporting high rate production. So the market has strong players, but the gap is real. Currently, the US is buying foreign made interceptors because available solutions are too expensive. They're not adaptable enough and rely on expensive fixed infrastructure. No single vendor provides an integrated airborne sensing package for austere environments with an affordable interceptor in one integrated system. Market entry path is also clear. We see 3 lanes: US-based defense, forward and austere operations, and protecting allied forces. There's a clear market signal from the US DoD and active RFIs, and evidence that serious contracts are being cut for non-traditional defense companies in this space. And we are pursuing pathways with multiple branches of DoD. So for the market opportunity, we frame this as a large but focused opportunity. Our TAM is $38 billion by 2030. Our SAM is 4.2 billion annually in the US and allied markets that we're targeting. Our 5-year SOM is $85 million based on a conservative bottom-up model. We believe that this is a venture scale opportunity with a specific market entry wedge. Our wedge is a validated sensing and edge processing node, which we then grow into a broader distributed swarm platform. We start with target queuing using RF sensing and electro-optical sensors and long-range directional communications. Then we integrate into command and control platforms and expand into affordable interceptors. Our team brings deep experience in defense contracting, product development, and scaling multiple successful startups. We lead R&D, product development, finance, operations, strategic growth, and market capture. Behind this team, we have 10 full-time engineers on site, specializing in software, aerospace, signal processing, electronics design, and composites manufacturing. We see a path from last year's $2.5 million in earnings to $85 million by year 5 with margins at over 40%. We are currently forecasting $12.5 million in recognized revenue for 2026. We're raising $5 million today to turn proven capability into scalable defense products. We are 100% self-funded with $750,000 already invested in R&D, and we plan to follow on. This $5 million raise funds flight testing, R&D, manufacturing, market capture, and key hires to continue building our engineering base. Over the next 18 to 24 months, this gets us into a validated reconnaissance platform, RF and comms products, integrated increased manufacturing throughput and capture readiness for large programs. Etherform is building on the right side of the drone cost curve. We already have the technical foundation, customer access, and engineering depth. We have the engineering and manufacturing facilities and the product to move now. Our goal is simple: detect early, field at volume, and respond affordably. Thank you.
Thank you, Chris. Questions?
So is this system able to detect RF dark drones, some of the drones that are used on the battlefield today? And is the interceptor able to intercept drones such as the Shahed drones? And have you considered drone swarms?
So the solution for RF dark drones, I assume you mean like fiber optic drones. Is that what you? Yeah. So the solution for that involves EOIR camera solutions. So there's a lot of nuance there with targeting using cameras. So yes, that's our approach as the visual spectrum for that. And we're interested in moving into acoustic as well. So as far as the Shahed drones, yes, we can target those. That's planning on leveraging the EOIR path for that as well, for targeting and steering. So how about the drone swarms? Yeah, drone swarms, essentially requires more. I've heard someone say, to defeat a swarm, you need a swarm. Thank you. Thank you.
Thank you so much, Chris. So next up is Aaron with Nav Unlimited.
Thank you, Joseph. Thank you. Our company is MAV Unlimited. We're commercializing the next generation of ultra-fast 3D printers. Our co-founders are Professor Robert Shepard at Cornell University, Professor TJ Wallen at MIT, and myself, a longtime Nike executive. When I was at Nike, my very first project was for Phil Knight. And he said, Aaron, get a group together and take a look and see if there's anything that could disrupt our business model on the horizon. We took a look, we came back to him and we said, Mr. Knight, nothing is on the horizon that might disrupt our business model. My thought process about that changed in 2009 when I saw selective laser sintering. And I said, wow, this is incredible. No need for investment in tooling, no need to chase cheap overseas labor, no long supply chains, no duties, no customs. You make everything locally and you make it for the individual, not the masses. And they said, hold on, Aaron, wait a minute. There's two problems with selective laser sintering and 3D printing in general. The materials are weak. They're just not strong enough to hold up to the durability requirements that we have at Nike. The other problem is it's expensive. I said, "Was it expensive? We don't have tooling, we don't have duties, we don't have all this cost." And they said, "Well, it works like this. So, conventional manufacturing, you have to invest in tooling. It's very expensive. But then as you get economies of scale, the cost per unit drops pretty significantly. 3D printing starts below that. So, it's really good for custom, it's really good for small batch, but it can't compete with conventional manufacturing at scale if you want to make 1,000 of something or 5,000 of something. We think with MAV, we're going to be sitting here. So we'll be a much better prototyping company, but we can also compete cost-wise at scale. Our printer is something called volumetric manufacturing. It's 50 times faster than the next fastest 3D printer, taking print times from over 5 hours to about 3 minutes for a statue like this Thinker statue here. And we can do it at roughly a tenth the cost. Speed and cost are our two biggest advantages, but there are three others that are worth mentioning. One is the materials that we use. So most 3D printing, you have to flow material either into a tray or through a nozzle. We don't have that constraint, so we can use high viscosity materials. What does that mean? It allows us to print engineering grade parts. The second thing is overprinting. So if you imagine our vial, you could drop a screwdriver shaft into that vial and print a handle around it. That gets really interesting for the world of electronics. So think audio earbuds that are custom to your ear, but also completely waterproof. This here is an optical connector. That's really interesting for people in the industrial sector. And then the third thing is we can print clear really well. So most 3D printing is layer by layer. We're building volumetrically, so it's almost all at once, so we can produce crystal clear parts. We've gotten some traction with the military. We were part of a DIU program that identifies us as a promising technology. It put 42K in our pocket and gave us preferred vendor status with the military. So no RFP, no cost competitive bid. We've also received 2 letters of support from the Air Force Research Lab saying that our technology would be a benefit to their mission. What specifically might we do in the world of drones and the world of the military? We could make quiet, attritable drones. So if you don't know that word, think attrition. You're sending out large swarms of drones. Chris was talking about large swarms of drones. Not all of them will make it back. We could be on the front lines producing new drones quickly. We see ourselves as a service company. So a lot of the drone companies in this room, we could be a partner to them to give them the parts that they need to make better drones. We can make drones in minutes, not months, at a lower cost with a reduced acoustic signature, and then tailored to specific mission requirements. So think wind, think weather. We can make adjustments in the front lines to get those parts correct. Military is definitely an opportunity. We see ourselves eventually pushing into the prime space. Consumer is really interesting. My background mostly. I'm really excited about the opportunity for eyewear. So think walk into Warby Parker with your prescription, hand it to them, choose the style of lens that you like, and then in a matter of minutes, get frames that fit your face perfectly and also the lenses integrated, all printed with our machine in a matter of minutes. And we talked about optical connectors in terms of the industrial piece. And you might say, right, Aaron, that's a lot of stuff. You got a small team, not a big budget. How are you going to accomplish this? We're starting with optics. And the reason optics is great is because we print clear really well. and it leads into all three of these different areas. So for drones, we might just start talking to a lot of my colleagues here in this room just with the optics of the drones and sometimes even the cover for the cameras for the drones. That would be a great place to start. In the industrial side, those optical connectors would be perfect for us. And on the consumer side, we're starting with Nike Swim. They make all their swim goggles in China today. They're getting killed on customs, duties, supply chain issues, and they're looking for a domestic alternative. We're going to start with prototyping and then hopefully move into production with them. So Nike Swim is a customer, Coast Electronics, which is here in Portland. Or nearby in Portland. They're the #3 flashlight maker in the US, #1 in headlamps. We're printing lenses for them. This is where their IP is in proprietary lenses. So we can do that domestically for them. They're also producing today in China. Our business model is B2B. As I said, we see ourselves as a service company. Our strategy is land and expand. Start with prototyping, which is the biggest pain point for our customers, and then gradually move into production. Ultimately, if we want to hit light speed in terms of our revenue, it's going to be about licensing and licensing to third-party manufacturing companies. We've got some wins that are noteworthy in Q1. Thank you, Joseph, for the program. It was exceptional. We really appreciate the participation. We've raised a little bit of money from Intrepid Oregon and Onami, if you know those organizations. We're in the engine. I'm joined by my colleague, Darshil Shah. That's a MIT-built lab that's in Cambridge that has welcomed us in. We have competition, so there's other people working to commercialize this technology. We've got the biggest machine by far and the fastest machine, but the competition's coming and we need to move quickly. We do have patent protection, so we've licensed the invention from Lawrence Livermore. And we also have Rob Shepard's patents from Cornell University that allow us to print much bigger. We've got an awesome team. Darkchill, I mentioned. Darkchill is applying for his O1 visa. If you don't know what that is, it means you have to have extraordinary ability in your field to qualify. So he came to us with his extraordinary ability, and we're happy to have him. We've got a lot of other people with extraordinary ability as well. We've got great advisors. My friend Sheila Marcel is a friend from business school. She took care.com from idea to IPO, and many others. Our ambition is to be a $500 million revenue company in 7 years. The key to that is the licensing piece and making sure we nail that. We have a note that's available now. It's led by Intrepid Oregon. We're raising $850K. We're a little more than halfway there. If you're interested, we'd love to build this with you. Thank you very much. Questions?
Yeah, two questions. What does your system offer in regards to printing of props? Because to 3D print props, they don't work, they don't tune right. And so that's something that we can't do on the edge. And then is there a plan to get more expeditionary with the capability so you could put it with a unit out in the field and be able to do the drone building and the prop building uh, and then make those adjustments right there?
Yeah, that would absolutely be the hope and the plan. So have it in a forward location, be able to print quickly. And then for the props, is it mostly a materials issue that you're seeing, the quality of the parts that are printed? Yeah, we can print to about 50 microns of resolution, and the surface area is really smooth. We avoid that layered process. So I can show you the little sample that we've got not yet perfected, but we should be able to print smoother, stronger parts than anything that's been done before. Okay, all right. Darshell, you got your assignment.
Any other questions?
Thank you.
So next up, we have Lorica Technologies. And so Chris.
Good afternoon, ladies and gentlemen. My name is Christopher Dye. I'm the founder and CEO of Lorica Technologies. I'd like to talk to you today about drone-assisted autonomous deterrence. The maritime security crisis right now results in $7 billion of annual losses in terms of piracy and theft, with a ripple effect of $25 billion across the greater economy. Right now, we're seeing those disruptions in the Straits of Hormuz, and we're seeing the effects at the price at the pump. We're not talking about the material supply chain disruptions as well, most notably the AI supply chain disruptions. Shippers right now are incurring a 10% war risk premium on their cargo per voyage. Oops, wrong way. Over the last few months, here are just a couple of the incidents that have occurred. On December 3rd, in Equatorial Guinea, we had a ship attacked and the crew taken hostage. We're looking at recovering those crews, generally cost between 10 and $20 million per incident in ransom fees. So, what if you could fight these terrorists further away from the ship? What if you weren't fighting them right next to the ship? What if you had time to move your ship out of harm's way and slow that threat down? That's why we're introducing C-Safe, drone-assisted autonomous deterrence. It's based around a FAA certified Class 2 airframe known as Barrelman that provides a 400-foot overwatch with radar, EO, and multi-signals systems. So we have an aerial perimeter of 25 miles and an engagement radius of 15 miles right now. And what we'd have is a fleet of scalable drones, a scalable fleet of drones that provide non-lethal interdiction services effectively. The traditional value proposition of maritime defense is having boots on your ship, fighting the terrorists alongside the boat. It's complex, it's limited. There's a lot of legalities that go into it in terms of getting those soldiers on and off the ship before they come into territorial waters. We're introducing C-Safe. Our package price per install is about $500,000 a system. It's consistent global operations with very limited operational restrictions. You get 24/7 AI ML Overwatch services that tie into our network, which we'll get into in a minute. And we have a real-time tactical operations center staffed by service members 24/7, 365 that handle all these incidents. How does the system work? Well, it's pretty straightforward. We use the SIP systems, use our systems, and we detect and we look for threats. We look for intercept vectors. We look for ships not communicating, and then we assess those. We assess those based on a number of different factors. And if we determine that that ship is a threat, we will send out a response. This is just some of the airframes that we have in the container on the ship. Like I said, Barrelman. We also have Siren, which is a class 1 for airframe, which is for communications for those don't wish to use the radio, as well as Sonic Denial as our first line of defense. Then we have Fox, which is our class 1 modular drone that carries our scalable series of countermeasures. We also have an extensive line of DoD and government drones. Just know that everything we've developed for the ocean, we can apply on land. We've done some really cool stuff with the software in terms of auto grid reference guide generation, as well as remote pin dropping, highly accurate remote pin dropping from even our smallest aircraft. So those are two things that don't really exist currently. I'd like to introduce you to our Lorica Mesh GCS and our Baldwin governance layer. Effectively, what we've built is a one-to-many ground control station that is works globally, and it's backed by what we call Baldwin, our governance layer that's Part 146 compliant from the get-go, that allows full chain of custody for all of your data, for all of your images, for everything that we're shipping over the network, and it allows all of the stakeholders involved the opportunity to review that footage, get access as necessary. Plus, it has a number of features that don't currently exist with any other ground station. Our intellectual property is a series of patents that cover our core, some patents pending that cover our core technologies. Our system is totally agnostic vehicle-wise. It doesn't care if it's a sub, if it's a ground rover, it's an airplane, drone, doesn't matter. Totally agnostic. The other thing we have is we've developed our own in-house proprietary zero trust authentication system, 160 kilobyte system. We just presented at RSA a few months ago to great response there. And every single one of our systems ship with this zero knowledge authentication on every single system. There's no more secure system for the commercial market than Lorica's. The competitive landscape for our industry is pretty unique in that we're the only people that have really looked at this issue and tried to solve it holistically. We kind of created the category. There are some other vendors that provide some parts of the system, but nothing comprehensive. DFEN does electronic countermeasures. Sail drone provides harbor and offshore surface reconnaissance, and then Fly for Future provides marine grade drones. Nobody's taking the whole package and putting it together into one comprehensive system. The market opportunity is as follows. The maritime security technology market is $28 billion globally. We're looking at the Europe-Africa market to go after first, and that has a service addressable market of $7.6 billion. We're looking at 5% of that market at about $380 million a year. Oh, sorry. Our revenue model is pretty straightforward. Each installs with our pilot customers is costing $500,000 per install, as well as annual recurring revenues of about $500,000 for service, warranty, all of the things that go along with servicing a product such as this. And that's the price for our launch customers. Our go-to-market strategy is we've built our drones, we've built our software, we've found our strategic partners, we found our early customers. It's now time to start our pilot projects with those early customers, get the data back from those, figure out how we're going to scale this and how we're going to put this on all of our customers' ships and their entire fleet. And then also, how do we engage with these adjacent markets? Our partners would like us to look at wind farm defense and onshore oil infrastructure defense. We brought our idea to Marsh McLennan, one of the world's largest retrocessionaires, one of the world's largest insurers of maritime infrastructure, and they embraced us. We have been working very closely with them over the last 2 years, and they provide us two pilot project customers, XMAR and CMB, both highly vertically integrated customers that operate in Europe and Africa, and are very excited to get our pilot projects going on that ship and helping them reduce their overall costs. The idea being that Marsh McLennan gets to reduce the risk for their customers. They get more perfect information themselves, and we reduce the overall war risk premiums. That's the goal here. Our timeline: we were funded in 2023. We started testing in 2024. We filed our patents in 2024. We optimized our software, started building all that, building our drones. Getting defense traction. We're working with Fort Bliss and the 3rd Armored Brigade, working on some very cool counter mine drone technology there. And then we're looking to break ground in our Tactical Operations Center later this year. Our financial projections right now, we're going to about $2.5 million this year from some of our smaller government customers. We're looking at about 20 million next year at the current rate. And then by year 5, we're looking at about 380 million, we hope, and $90 million in income. Time. Okay. The executive team, it's myself, Ryan Austin, and Lane Yago. Lane's been at Google for 20 years. Ryan's a special forces soldier, and he's got 4,000 hours on small UASs in combat. We have an extraordinarily great team from Boeing, 5 Lunds, Bigelow Aerospace, Verizon, NSA, so on. I'm really proud of this team, but I'm going to move real quickly through here. Again, we're trying to raise $7 million for expansion and deployment of our systems with a $2 million previous investment round. And thank you for your kind attention.
That's it. First, got a question here. You got to answer.
Hey, thank you for your presentation. I got a question and comment. So, question on the product side. Are these aircraft, are they your hardware that you're developing, or is it the software that's stacking on top of that? That's the first question. And second is it a common autopilot system that you're basically operating through Lorica?
Okay, so we do build the hardware and the software. So our hardware right now is we do use some off-the-shelf stuff, but we are now converting to our own dedicated boards now. So we do the software, the hardware, the integration, as well as all of the AI written that we use to do all of these tasks that we need to do. Autopilots. We use a common autopilot. Yeah, I mean we use it's Mavlink run, so it's yeah.
Perfect. And then comment, Transported Asset Protection Association. I'm assuming you already know of them, or if
we know of them. We're not a member. We're
Okay,
not.
now,
We've been working very closely in our little pocket. And
everything you're doing here for maritime on the ground side, pistachios, Kit Kat, the ability to protect on land as well.
Sure. Yeah, that's we just, we're a small company. We had to pick one market to go after first. We picked this, and but now it's people are coming at us about offshore wind farms, onshore wind farms, infrastructure, the offshore LNG fueling platforms. So there's endless possibilities in terms of using the system for defense.
Perfect.
Yeah.
Great job. Thanks.
Thank you so much, Chris. Next up, we have James O'Lean with American Tenet. James, welcome to the stage.
Thanks. Hi, my name is James O'Lean, founder of American Tenet. We build simple, low-cost decoy drones designed to deceive the enemy and keep America's allies alive in tomorrow's battlefield. Modern warfare, it's evolving. Drones started as experiments in Vietnam and became exquisite and expensive systems in Iraq and Afghanistan. Now, Ukraine has pivoted towards low cost and low tech solutions. Today, our board member, pictured up here, is flying F 15 Eagles out of Jordan, shooting down $35,000 Iranian drones with $500,000 US missiles. And that is not sustainable. If there were a conflict with China tomorrow, American Tenet wants to help Admiral Prospero turn the Straits of Taiwan into an unmanned hellscape. General Patton said it best: make the enemy react to you. So we're flipping the script. Instead of protecting everything, we're deploying one way, fire and forget, expendable drones as a force multiplier. Here are four of our designs. Here are four of our designs that we've built, are testing, and demonstrating. We want to put a big, fat, loud pig in the air and have the enemies pay attention to that instead of what's going on elsewhere in the battlefield. We force the enemy to react and expose their tactics while shooting their expensive munitions at our cheap systems. Our drones have other uses in the battlefield: target practice and as one-way payload delivery vehicles. Our team of Army, Navy, and Marine engineers served in combat as drone operators in both the Pacific and Middle Eastern theaters. Our goal is to deliver a new decoy drone design every month during combat to ensure that the enemy doesn't adapt to America's drone strategy. We filed our IP early to protect our technology, and we've already secured 4 provisional patents and have 16 on deck to submit. But our real value proposition is simple designs, rapid iteration, and the ability to manufacture at scale faster than our competitors. This is already a real market. Globally, decoy, training, and payload delivery drones represent a $3.2 billion opportunity. The US government is spending nearly $880 million to solve this problem 2 years ago. Our initial focus is narrow: a single contract worth $34 million of revenue in the first year, growing to over $300 million by year 5. The Department of War is already a customer. They've invested over $1 billion for attritable drone research, nearly $250 million for the US Army to acquire decoy drones, and over $35 million to develop decoy drone technology specifically to emulate other drones' radar cross sections. We're facing well-funded competition who have expensive and exotic systems. But our nearest competitor, it's Russian, a company called Gabera. They produce 3,500 decoy drones a month and sell it to the Russian Ministry of Defense for $10,000 per unit. While defense primes slowly research decoy drone technology, we're doing it here today in the United States. And we build affordable, manufacturable, and expendable systems. We enter at the Army division level at $10,000 per unit. That expands into operational contracts, roughly $34 million annually. From there, we'll target additional contracts and look at $300 million in revenue by year 5. This is a pure defense tech hardware sales play. 3 customers have already engaged with me: the Chief of Staff at Air Force Futures at the Pentagon, out in Brussels in NATO at the Innovation Lab, focusing in on counter UAS,
And just a couple weeks ago, I had a discussion with the defense attaché from the Embassy of Romania in Washington, D.C., who's invited me out to Bucharest to discuss our technology. We will enter the market through Army and Air National Guard units. This will give us 114 times at bat to make our sale. Their budgets are a little different. It's both state and federal funds. And we can land and expand while maturing our technology for active duty contracts in the future. With just one contract, we can bring in $34 million in gross revenue with a 75%, nearly 75% gross profit margin. At scale, production costs are approximately $8 million. That supports $34 million in first-year revenue, with strong margins and additional contracts worth more than $300 million in 5 years. This is not a concept stage company. We're Army X-Tech winners, are members of NVIDIA's Inception startup program, Portfolio to Capital Factory, alumned at Mass Challenge. We published on dual use defense technology at MIT, incubated at the University of Texas, and we have a federal marketplace competitive advantage with Ability One and can turn federal contracts into sole source non-compete. They'll last forever. Plus, we have our own factory down in Texas, and we're ready to turn the lights on. We're raising $2.5 million to develop $307 million in revenue within the next 5 years. We'll deploy this investment to immediately onboard our engineers to continue our R&D and actually start making these drones. We'll complete our patent filings over the next year and submit more. We have a strategy to engage with our lobbyists on both federal and international contract opportunities. Through the National Guard units and Army Vulcan, we will expand our pilot and demo opportunities. And we're working with our partners at the University of Texas Institute of Advanced Manufacturing to develop our automated manufacturing process and reduce our cost per unit. In fact, the city of Edinburgh has granted us a 5-year no-cost lease to a 50,000 square foot production facility on the flight line at their airport. I've solved problems with my teammates for more than 20 years, both in and out of uniform. From deployments in Iraq to time in government and with the defense tech primes, we've learned the business. We understand both the operational need and the acquisition process. Our advisors, they bring their hands-on logistics, sales, research, and finance acumen to help push our projects forward. We're building decoy drones for deception at scale and can see revenue within our reach. Today, we begin our raise of $2.5 million off a convertible note and hope to close within Q4. If our strategy matches your thesis, I'd love to chat afterwards. Thank you for your time.
Thank you, James. Questions?
Hey, James, thanks for the presentation. Could you talk a little bit about the distribution? Are you going to have a centralized manufacturing plant in Texas and then trying to distribute nationally or internationally?
Yeah, actually, the port of Corpus Christi nearby is being turned into a deep water port to rival that of New Orleans, and it's both federal and state money. The National Rail actually heads down in McAllen, Texas, where we'll be located, so we'll easily be able to transport our end product to the ships at sea and out to the rest of the world.
Any other questions? We all good? Awesome. Thank you so much, James. So next up is Kian. Let's see, with Prairie Schooner. And I have to say a word about Prairie Schooner. We're very, very proud to have them a part of our accelerator program. They are our only international startup, and they are from South Korea. And so super, super good to have them here. And Kian will give a great presentation.
Thank you. Thank you, Joseph.
Hello, everyone. I'm Kian Kim, and co-founder and CEO at Prairie Schooner. We are building Pegasus, a natural language voice AI command and control layer. Our goal is simple: to help one operator control multiple autonomous assets more intuitively and more efficiently in tactical edge environments. The battle space is shifting to mass autonomy. Success is no longer about how many drones you can supply. The real challenge is coordinating thousands of systems with fewer operators. In this new era, command is the bottleneck. Today, the biggest bottleneck is the human operator. First, the traditional one-to-one model simply does not scale. Second, training takes up to 120 hours per operator. And third, every new system, upgraded system require costly retraining. The problem is not a drone, it is control complexity. Pegasus shifted this paradigm from manual piloting to mission intent control. Why voice? Because voice is already the standard language of the battlefield. We leverage existing radio workflows, reducing training from weeks to just hours. Now, one operator can lead multiple assets as easily as talking to their team. How does it work? Pegasus runs natively on tactical smartphone and ATAC devices. First, our on-device AI captures voice command in offline and high-noise environment. Next, it converts that natural language into structured mission intent, automatically planning and dispatching across multiple assets. Through our open architecture, we integrate seamlessly with Blue UAS and other platforms. We are not just doing speech recognition. We are building the command layer that turns intent into action. Why now? Because the DoD is deploying happens here in the US over the last 12 weeks. We onboarded a three-star general as an advisor. We are no longer just a concept. We are validated in the field. Here is the proof of our journey. On the left, our initial concept demo with Army Futures Command. In the real world integration right here at the Pendleton UAS range. And on the right, as I mentioned just 3 days ago, we put Pegasus directly into the hands of Oregon National Guard soldiers. Through our interface is highly intuitive. More importantly, we identified the exact roadmap for our future upgrades. This works for the soldiers. How did we move so fast? It is because of this purpose-built team. As a former artillery instructor who directed over 7,000 live fire rounds a year, I know exactly what commander needs. My co-founder, Dr. Lim, is world-class AI architect. Is over 8,800 citation in security ensure our AI architecture is absolutely bulletproof. To fuel this momentum, we are raising a $2 million seed round. This gives us 18 months of runway to hit 3 key milestones. First, delivering our swarm-ready command prototype. Second, securing 3 to 5 US defense pilots. And finally, landing our first multi-year production contract. None of this rapid progress would have been possible without Oregon's incredible UAS startup ecosystem. It is a true honor to be a part of this community, and I'm deeply grateful for support. If you want to build the future of tactical AI, let's talk. Thank you so much.
Keon, thank you for your time and your passion. Can you expound a bit on the agnostic capability? So you said it's could be applied to any tactical edge device that we might be using. Could you explain how you plan to get there on that front?
Uh, we already integrated our solution in a tag system, but we we don't depends on a tag system. We depends on Android and neural processing unit, so we can expand our solution to other GCS and other Android-based controller, so we can connect our software and other type of uh, all kind of UAS and UGV platforms.
On the hardware side, do you need the OEM to integrate, or can you integrate without the OEM support?
Uh, we we uh we already signed with Parrot HQ, and first we integrate our solution with Open SDK about Parrot SDK, but we have a meeting about integrated about their state of art Ukraine Parrot version. So we need a discussion about OEMs. Yeah.
Perfect. Thank you.
Thank you.
Thank you so much,
Thank you.
Keon. Appreciate it. All right, next up, Osprey. Not sure. Is it Rick? Okay. Great, Rick.
Thank you. Hi, I'm Rick Hanberry, CTO and co-founder of Osprey. We build passive counter-drone early warning systems for small teams on foot. The people we built this for are dismounted warfighters, a squad leader, a special operator on patrol, no vehicle, no generator, no fixed site, just a team and a threat they often can't see coming. Osprey gives them warning time, passively, without giving away their position. The threat landscape has shifted fast. July 2025, Russia launched 728 drones in a single overnight attack. A $500 drone can disable a multi-million-dollar vehicle. Low-cost drones are now massed, attritable weapons. And the people most exposed are the ones on foot with no warning. And the threat is coming home. DHS recently testified that more than 27,000 drone incursions occurred near the southern border in just 6 months. Drone activity disrupted El Paso International Airport in early 2026. The threat has outpaced portable defenses, overseas and at home. Most counter-drone systems are built for fixed sites, command posts, vehicles, forward operating bases. They do not move with a dismounted team. Active radar and RF systems reveal their position the moment they switch on. And they demand power infrastructure small teams don't carry. Enterprise systems run from $500,000 to $2 million per unit, pricing that doesn't scale to small teams. And most affordable systems rely on a single sensor. Acoustic alone misses some threats. Osprey's answer is hear it, see it, use it, hand it off. Arrays with electro-optical, infrared, and shortwave infrared imaging. The acoustic array hears the drone before visual contact. EOIR, SWIR sensors cue the targets, visually confirm the threat, and support classification. Onboard Edge AI fuses the sensor streams in real time, cutting false positives and building a confirmed track. That track hands off directly into ATAC and cursor on target workflows, tools operators already use in the field. Zero RF emissions, no fixed infrastructure, all processing runs on device, even in GPS denied or contested environments. Four things separate Osprey from everything else in the space. We are fully passive. We never emit RF, are targeted by the drones it senses. Backpack portable, designed for dismounted teams with no vehicles or generators required, which delivers confirmed threat classification, not just an alert. And we're open and interoperable, ATAC and cursor on target native out of the box. Here's why that advantage lasts. Multi-sensor fusion is an architecture gap, not a feature gap. Acoustic-only systems have a performance ceiling that doesn't close by adding software. Closing it requires redesigning the sensor stack. Our provisional patent and early DevCom engagement builds the technical and relationship foundation that compounds as we deploy. Price for real deployment, mid five figures versus 500,000 to 2 million for fixed site alternatives. The table on this slide shows where Osprey stands relative to Squarehead, RF-only systems, and RF detection and jamming systems. Squarehead is a credible acoustic detection company, deployed in theater, ATAC integrated. We respect that work, but Squarehead is an acoustic node. It hears, it does not deliver a confirmed visual track. Acoustic gives you a cue. Osprey gives you a confirmed, classified track handed off to ATAC that is the difference between an alert and actionable information. The column that matters most for this mission set is confirmed visual track. Osprey delivers it. Osprey is early stage, and we're moving on a disciplined schedule. TRL4 was achieved in August 2025. TRL5 is in progress now. We are targeting TRL6 in August and TRL7 by November, which means evaluator-ready systems for military and agency assessment before the end of this year. 2 safe notes closed, operator validation complete, provisional patent filed. Early technical engagement is underway with DevCom, C5ISR, and Armaments Command stakeholders. The buyers are funded. Sorry. The buyers are funded. The requirement is validated. The window is open right now. Joint Interagency Task Force 401 is centralizing joint counter-UAS development. In January 2026, the Army specifically solicited low-swap acoustic detection for dismounted Group 1 and Group 2 threats with TAC integration. That is a direct description of Osprey. DHS and FEMA have both expanded counter-drone funding significantly. The total addressable market is over $30 billion. Our serviceable market is $5 billion. Our obtainable market for the first 5 years is $65 million, won through U.S. defense first, allied militaries next, partner-friendly by design. The business model is defense-proven and straightforward. Hardware first, mid-5-figure system price, 40 to 60% gross margin at volume, initial pilots and limited procurement. That's how this channel opens. Recurring revenue second, software updates, model improvements, sustainment contracts, training and support layered into the installed base. DoD sustainment is sticky. Once you're in the logistics system, upgrade cycles are predictable. Scale third, allied militaries after the export path is clear, critical infrastructure after defense validation, larger contracts, and longer buying cycles. The $65 million serviceable obtainable market does not require market saturation. It requires winning a narrow, funded use case and expanding from it. This chart reflects how we expect revenue to actually develop, following technical maturity and evaluator adoption, not a hockey stick assumption in year 1. Evaluator deployments in year 1, initial procurement in years 2 and 3, follow-on programs and expansion carry us to $65 million by year 5. Our team is built for this problem. Ian Doyle leads strategy, fundraising, and go-to-market. He brings Lockheed Martin business development experience, and he understands how defense acquisitions actually work. Adam Doyle is our Chief Strategy Officer, 30-year Marine, 13 combat deployments, MARSOC, JSOC, DIA. Every design decision goes through his operational lens. He's the reason Osprey is shaped around real mission needs, not assumptions. I lead all technical execution, sensor architecture, multi-sensor fusion, and edge AI. Mike Brown joins us as a strategic advisor, bringing hardware commercialization and cyber strategy experience from building and scaling defense hardware companies. Behind us is a broader network of advisors spanning defense manufacturing, operational expertise, applied science, and IP, with direct experience in the markets and acquisition channels we're entering. We are raising a $1.5 million pre-seed round. Engineering and integration accounts for roughly 40% of that. Ruggedized prototype builds, 25%. Key technical hires, 20%. Evaluator readiness and partner engagement, 15%. That gives us an 18 to 24-month runway to TRL7 and first evaluation contracts. TRL7 evaluation contract is not just an engineering milestone. It is a gate that unlocks Cyber Phase 2 and early DoD procurement funding. It converts a credible prototype into a government-validated system. That is what makes us financeable for the next round at better terms. We're building the tool that the people on the front lines need. Every design decision is made with those people in mind. This round moves us one critical step closer to putting it in their hands. Thank you. If this aligns with your thesis, we welcome the conversation.
Questions? Questions? Yeah.
Thanks for the presentation. And I guess I have a technical question. With a vision and audible detection system, what is the range of the detection that you are seeing so far? And what is your target range for the production units?
We're TRL4, so we're still building in lab. Our target range right now is greater than 400 meters. Inside of that, you lose the sort of value of having that sort of sensor modality. So greater than 400 meters. Our ideal range is a kilometer, but 400 meters is our target right now.
Thank you.
You had a question? Okay, good. All right. Thank you so much, Rick. Appreciate it.
Thank you.
Oops, you got the clicker. Sorry. And so we're, thank you. Please give a round of applause for all of our 6 second session pitch startups. Please scan the QR code again. This is your chance to vote for your fan favorite from group 2 or session 2. Please scan it and take your vote. I'll give you a second to do that here. And just for everyone's information, all the pitches have concluded. We will tap, and then just for everyone's information, once we have handed out the checks, and once we have a break, we will have all of our startups and judges kind of gathered at this end of the room. So if anybody has any questions or want to get to know our startups a little bit better or judges better, please feel free to come over to this side of the room. So thank you so much. Oops. Yeah, that might.
Great. Thank you. I'm so glad I'm not having to judge this. Oh my gosh, it's just